All right, this is great. What a great crowd. It's nice to see a full house. So I'm Adam Barrett. I'm the owner of Apex Ridge Reliability Consulting. It's a consulting firm based here in New England, but we do have customers worldwide. And we specialize in all different reliability tools and analytical and organizational methodology. So that includes specialized testing methodologies, analytical methods, education programs, reliability growth, high-level system development programs, as well as organizational improvement methods for having reliability practices be integrated into your program. And that's the first part of what I want to talk about today. We'll be doing today in 3 sections. The first section will be regarding balancing reliability activities in a product development plan. The second part will be talking about a lot of different reliability testing methods and how those outputs can be used as inputs or should be used for inputs to help measure and improve the product and have that be used as metrics for the program and program decisions. Our last section will be on specialized Hall testing methods and also how derivatives of them can be used in HACCP testing and other manufacturing testing methods. And then we'll be doing some demonstration work on HALT here at New England HALT Labs. So this is a challenge that I believe a lot of reliability organizations have to deal with and programs deal with. And I don't think a lot of discussion or attention goes to setting up in advance the right methodologies to help make this happen. So I wanted to take some time to talk about the experiences I've had, what I've learned, and some of the methods that I've used to improve this process. So hopefully I can do this in a way that shares a lot of stories and things that are familiar to you, and I really look forward to your questions afterwards as well. So at the beginning of a program, we start with a couple of things, and they feed into what ultimately becomes a product specification document, and that is often then used to drive the program and program activities. So we have things like technology inventions, we have market analysis. A lot of work has been done in there in figuring out why do we want to make this product, what's the return on investment going to be, it's a business. We try to find out what the niche is and optimize a lot of different factors around that, and by factors I mean a lot of things like what's the cost point of the product, what's the time to market that we want for this product, what features need to be included, and what reliability is part of the product. And the reliability also extends to the brand. Is your brand a brand that's heavily based in reliability, or what percentage is it? It's not that every product needs to be perfectly reliable, or that reliability is going to be a key decision factor. You have to know what your customers are looking for. So we start our story with creating this product specification. A lot of work goes into that, and a lot of levels of the organization are involved in that. So let's go to the day of product release. It's an exciting time. All this work has come to a culmination of getting ready to put it out in the world. And what we're hoping is that product plan is going to be reflected in this product and as it goes out. So as we roll forward, say a few months, about 3 months, some things start to happen. We start to find that we don't have control of the product, maybe as well as we had hoped. And also sometimes the way the product is performing or how we're hoping it ends up implementing those original goals might not be exactly as expected. So let's go forward a few more months. Let's go forward about 6 months. A few small issues have popped up, and this, in a lot of cases, is just considered part of the process, right? There's a little bit of maturing of the product that happens in the field. And you have a continuous engineering team and your manufacturing team, and they're expecting this to be a part of their tasks of managing this as it rolls out. And there's resource actually allocated for this. So everybody's still like, it's OK. We give it cute names like, oh, these are the gremlins, right? You've probably heard that term. Oh, these are just the gremlins. We're just working out now that it's been released. But then something happens. What happens is 1 or 2 issues start to spike, and they really spike. And they're happening across your entire customer base. And they're very visible, and it gets the attention of the entire company. So now all of a sudden, this is beginning to affect not just this product release, but other product programs and the organization as a whole. I don't know if people have been a part of this kind of a panic mode. I've participated in it before, where the executives begin to, on their own, schedule meetings every week or every day or every other day to address these two issues that have come up. It doesn't just affect the product, it affects the company. So as this is happening, everybody's trying to figure out, what do we do next? Well, basically, this is what's happened. The problems have found you. Do you like my graffiti? I made my own custom graffiti. MTBF sucks. Why vote right? MTBF does suck, by the way. It's like the worst reliability metric ever. That's actually a photograph. I did do that in a building somewhere. That is it. So this is where I find an interesting mindset. There's this idea of like, oh my God, these two problems came out of nowhere. That's not the case. They were always there. They just finally found you. They found you. They were there. They didn't occur because something wasn't in control. It's because you didn't put enough margin to manage what was occurring. So this mindset difference between the problems were always there, and they popped up, I think is interesting. There was in that exact moment I experienced was captured once, and I can share this photo because it was from a Popular Mechanics article, and that's me in the corner. And this is the Boston Dynamics robotic mule. If you remember, about 3 years ago, there was a lot of press coverage on this, and it was a robotic mule that was being developed for the Marines. And I was brought into a system with improving the reliability at the stage after they got it going. How do we get it to where it can perform as needed to do full missions? Because you're out in the woods, with your team, and you can't have failures. So this one day that was covered was one of the first days we had the Marines in, and they were using the product. So now we're getting to see the difference between how we thought it was going to be used and how it's actually going to be used. Well, the Marines like using stuff as battering rams. We didn't, like any equipment they have can be used as a battering ram. It makes sense, right? Because they're going through all kinds of terrains, and they need to effectively clear a path. And there was some knowledge of this. You can see the big frames all around the mule. And the mule was able to, with such good sensory, it could tell the difference between leaves and hard objects, and it knew it could like walk through leaves, and it could of course differentiate between different diameters, trees and things, and if they're small enough it just would go over them. If they're big enough it would do everything it could to navigate them. And it could navigate itself given a destination or to follow somebody, but it also could be manually controlled. At this moment it was in a mode of manual control. And if you can see here, this tree of about 3 inches in diameter is jammed in the shoulder. It went into the shoulder. It couldn't free itself. It was stuck in there so deep, and it ripped apart sensory that was in the shoulder. And so at this moment, everybody was really upset. The engineers weren't happy. The Marines were quoted in the magazine as saying, "It sucks that I broke it." That was the headline for that page. "It sucks that I broke it." I am so happy. I'm the only person that is so happy. This is why I was happy. From my perspective, we had only built 3 of these units so far, and had very limited opportunity for reliability testing because they were being used for development and other kinds of testing too. So in my mind, this thing has 2,000 things wrong with it. 2,000 problems, things that haven't been developed, aren't mature. And what are the odds I'm going to really find the big ones while I get to do a testing program? How lucky did I get that I got to see a 3-inch diameter tree is a problem that we had not accounted for, effectively a third category that wasn't the stopping it from going forward category and pushing it over category, is to get stuck in a category. And so this obviously was a very easy fix as far as a redesign, because we just changed the way the shoulder structure was, the way things were protected, the way sensors were. It's not going to happen again. So this didn't happen to the team out there. This was able to happen for us. So this was a really great moment, because this wasn't going to be the bull that found us later. So let's go back to these 2 issues that are dominating what we are dealing with. So we're in panic mode. We're trying to figure out how to address it. We start hearing things like, should we stop production? We've all heard that. Should we just stop because we have a 20% failure rate? That means the more we make, the more we have out there failing. Or should we try to give the customer, opportunity to ramp up manufacturing again on the previous generation, right? Let's get that in their hands and get us at least back to that point when things are okay. And then, Very commonly you hear the let's put a tiger team together. And I think a lot of us are familiar with that, right? With that idea. And that's a lot of times where we settle in our first point of action is. And the tiger team is when you kind of have an all hands on deck. Everybody who can possibly help with solving these two issues gets involved and has an extremely high percentage of their time dedicated to it. That means the R&D team that is now on a different project, they are going to stop working on the next new generation product and pay attention to this. That means that continuous engineering and manufacturing team are no longer working on all the challenges of rolling this out. They're only focusing on this. Project managers are now back on it. Executive staff are involved with it. I mean, it is debilitating. I mean, so much resources going to this team that is just trying to address these two issues. So we get to this point, we have our tiger team, and they have this one goal, this one thing to get control of. So that's a hard point. That's a hard point in our program. Let's roll back in time to a better point in time, something a little bit happier. Here is our product development plan with, it has all our different goals. It has our time to market goal. It has our features and functions and latest inventions we have included in it. It has our reliability goal. It has our cost point goal. That's all in there, very clearly defined, wrapped together very nicely, and going to get us to where we want to be and grab that market share we want. It's good. So let's talk a little bit about that part of the strategy. So this is a graphic I've created when working with some teams to help understand, okay, you have all these practices and places you want to put resource. Design for manufacturing, design for cost, and having certain functions. So it's really a balance. You have X amount of resource to this. How are you balancing the resource? So you can throw this X in here with, in this case, these 5 goals: serviceability, manufacturability, cost, features, and reliability. So let's take a product that we're all very familiar with and throw it on here. This would be an iPhone, okay? So this iPhone, it's very clear where they've decided to set this balance. They've put it over towards reliability and features at the sacrifice of manufacturability and cost. So what are some indicators of this? Well, they use screws to hold the case together. So the decision for screws clearly, instead of snap fit, is a big no-no for design for manufacturing. When you want to design for manufacturing, you want less parts, less steps, less variability. Screws are against all those things. But what screws do is, if you've decided your use case profile includes this thing being dropped every so often by the customer, screws are going to hold it together better. If you look at features, there's of course many impressive features and high-end cost components in here, but they have an aluminum case. So aluminum case obviously helps with the reliability, but you can also make plastics, fiber-filled plastics that do that. The aluminum case is really, it's part of their brand, right? It's kind of a feature of the phone that makes it unique amongst the others. But that obviously, cost of aluminum versus plastic, a huge difference. So you can see where they've chosen to balance their goals. Let's look at another product. This is a consumer level drill. So this is the drill you or I would buy for our home. Here, they've put the balance very much towards manufacturability and cost, and sacrificed reliability and features and serviceability. And this was exactly the right thing to do. They knew what their niche market was, where success was going to be for a consumer. So some of the things that reflect this are, you have plastic casing instead of metal. This is very cheap to make, but obviously potentially less reliable over a very long time or a very high duty cycle. But that makes sense. You or I, how often do we use our drill at home? A few times a month, right? The duty cycle is insanely low. Secondly, if it breaks, I get to go back to doing whatever I was doing that was fun, and I can finish the project tomorrow. I'm kind of happy. I have an excuse for not finishing the honey-do list. I really don't care that much if it breaks. It's not a big deal. So I would much rather have lower cost than extremely high reliability. Features, it really only has a pull trigger button and a directional switch, and that's it, and no other features. So if you look at this in comparison to, in contrast, a contractor grade drill that could easily be 10, 20, 100 times more cost, because you can buy these for under $20. The contractor grade drill is a very different balance. It's more like the iPhone. Reliability is everything. Do you know why? when this thing fails, you have people standing around the job. Your dollar clock is just running. So this one piece of equipment that by comparison to how much you're wasting that day costs nothing. So you want reliability. And even things like design for manufacturability. This thing actually has less screws holding it together than the iPhone, which is amazing. Most of these plastic components just fit into each other and lock together and just need one last hinge to keep them in place. So they took the time, they created that very specific product level document and implemented. So I just think this is very interesting. It doesn't take much time to do. You can do it for your own product and kind of get a good visualization for that initial product specifications that were set when you started your program. So we have that initial product development document, and we want it to result in our end product reflecting it. So we picture this happening with our team, right? The next step after creating it is handing it off to our team. And we picture them taking all those goals and working with them all individually and with regard to their discipline and their objectives. And it's a constant part of it. But let's stop for a minute and be honest. What really happens? This is what happens. Everybody grabs one goal that they give the most weight to with regard to their function, their role, their discipline in the project. They will find one that is going to be most attributed to their success. And this is reinforced by the organization as well. This is a strange, almost level of sabotage that the organization does. They're totally unknowingly. If you ask a project manager what is most important in a project, they're going to say, time to market. Nothing else matters. Time to market. We got to get it there on time. You ask the R&D engineers, it's got to have these features. So what's happened now is you have individuals who have each grabbed a goal that is associated to their success, and it's not just in their mind. What do you think the project manager's bonus is tied to that year? Time to market. What do you think that R&D engineer is going to get the promotion based on? They developed this next new great technology. So it's very strongly enforced. I mean, I stop and think about it. I've been a reliability engineer on programs and been very frustrated. And I've taken a moment to have empathy for my teammate, for my colleagues. I'm like, I'm a reliability engineer. If you put me tomorrow in the project manager role, to keep my job, I would sacrifice reliability activities to make sure we hit time to market. Like it's not even a matter of being self-centered or selfish. You really have no choice. And the organization doesn't realize they've done this, right? And they're effectively beginning to contribute to their own issues with success of the product later. But since you've now made it personal, you've also brought in a lot of other things. You've brought in some of the natural competition that happens between organizations. They're going to use these goals for their own success and gain and power. There's always empire building and competitiveness. So now you've taken it and brought other dynamics into the imbalance of your product goals. You've brought in all your other organization and other higher level contributors. So now it gets really off balance really fast. So the way this ends up actually unfolding is what I call a dominant priority method. And it's effectively simple rank ordering. What occurs is at any specific point in the project, there's one thing that dominates. Like all you hear is time to market, time to market, time to market. And then all of a sudden they realize cost point's a problem. Cost point, cost point, cost point. Oh my God, we're not going to be able to make it for $5 each the way we planned. Now that becomes most important. And then this goes on, and things keep flipping around. It's analogous to if you picture driving your car, imagine using the rumble strips as your feedback that you need steering input. What would that be like, right? You'd be just drifting off, you'd hit the rumble strip, you'd panic, you'd go the other way, you'd panic. It's very inefficient. Passengers not that happy, right? And with regard to getting your goal, you're going to get there slower and have wasted a lot and worn out your car. Now, compare that to the way we do actually drive. We keep our destination in mind, or straight in front of us, our eyes on it, and we do a lot of these very small, almost invisible corrections to where another observer, we're just going perfectly straight towards our destination. Very efficient, very fast. So why aren't we doing that? So I stopped to think about why does this happen? Why do we end up in this rank priority method instead of these other methodologies that we use in other parts of our life and even at work in programs that clearly bring much more efficiency with this other ways of